Welcome to our JAMB revision series. There are a few things I want you to know as you are preparing for your JAMB exams. The first thing is that JAMB set question based on the syllables. The second thing is that the questions are set to just see your ability to interpret it. When it has to do with physics, it is more of the application of what you know already. So what are the things you should do? Some of the things you should do are: one, try to practice as much past questions as possible. Two, try to see how to make some adjustment to questions and see, like asking yourself, if they say this question in this way, what will I do? When you do some of those things, you will discover that there is high chance you will score 80 and above in every subject. Today, I try to bring up top topics you will always see in JAMB exams. Let's start with question number one. The dimensions of electromotive force are dash. You will agree with me that dimension is a regular topic in JAMB. So what is the secret now? To know how to interpret it. Once you know it, you are good and fine. In this question, you need to know what is the formula for electromotive force. Remember, electromotive force is not an example of force. Electromotive force is like when we have a battery and it is not connected to external source. The energy there is what we call electromotive force. It's mostly, we use it as EMF. This has to do with work done divided by charge. What is work done? Force times distance over charge. This will give us kilogram meter per second squared. That comes from force. Remember, force is, you can say, mass times acceleration times distance, which is meter, divided by charge is current times time. Let's rearrange this. We have kilogram meter squared per second cube per ampere. This is the SI base unit. For us to get the dimension, our kilogram will take m, our length will take l squared, our time t minus 3, and our current I minus 1. Our option is A. Question number 2. Force Newton, torque Newton per meter, current ampere, power watt. Which of the above are the correct SI units of the quantities indicated? You can see these are things we have done before. It's for us to now know the right one. Force is measured in Newton, correct? Torque has to do with force times distance. That's supposed to be Newton meter. So this is wrong. Current is ampere, correct. Power in is what? Correct. So 1, 3, and 4. That is D. Question number 3. The resultant of two forces, 12 Newton, 5 Newton is 13 Newton. What is the angle between the two forces? For us to get that, we can consider a squared equal to b squared plus c squared minus 2bc cos a. We are looking for the angle for the two of them. Now this will give us 13 squared equal to 12 squared plus 5 squared minus 2 times 12 times 5 cos a. This will give us 13 squared, that will be 169 equal to 169 minus 120 cos a. 169 to the other side, that will be 0 equal to 120 cos a. That means a will be cos inverse of 0, that is 90 degrees Celsius. Our answer there will be C. Number 4. Which of the following is not a vector quantity? Altitude, acceleration, displacement, weight. Altitude is distance. That is not a vector quantity. Number 5. A force F is required to keep a 5 kilogram mass moving round a circle of radius 3.5 meter at a speed of 7 meter per second. What is the speed if the force is tripled? For us to get this, we have to consider F equal to mv squared over r. Let's find the force. That will be F equal to 5 times 7 squared divided by 3.5, and this will give us 70 Newton. They ask for the speed if the force is triple. If force is triple, that is 3 times 70. That will be 210 Newton. So we look for speed. F equal to mv squared over r. To find speed, that will be force times radius over mass square root. So V will be equal to square root of 210 times 3.5 all over 5. The answer will give us 12.1 meter per second. This is a new pattern of how questions are set. Question number 6. If a wheel 1.2 meter in a diameter rotates at 1 revolution per second, calculate the velocity of the wheel. In this case, we have V equal to omega r. So this will be 2 pi over t radius. But they gave us diameter. We have to divide it into 2 to get the radius. This will give us V equal to 2 pi over t times 0.6. This will be 2 pi times 0.6 divided by 1. Why is it 1? Because they said 1 revolution per second. That per second means 1 second. This will give us 3.6. Question number 7. A ball of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces 6 and 8. Calculate the acceleration of the motion. Now you see, this is resultant force equal to mass times acceleration. In this case, the two forces are perpendicular to each other, 6 and 8. We will first find the resultant force before we use it. Now, resultant force there will be, we apply Pythagoras rule, 6 squared plus 8 squared. This will be square root of 100, which is 10 Newton. This is the force we will use. So 10 equal to 4 times A. A equal to 10 divided by 4. That gives us 2.5 meter per second squared. These are the new pattern of questions. You have to ensure that you know how to navigate through it. What is the frequency of a vibration if the balance wheel of a wristwatch is 90 revolution per second? Here you have to find frequency. What is frequency? Number of oscillation divided by time. That will be 90 divided by 25, and that will give us 2.27. Question number 9. If a ball of mass 5 kg is thrown vertically upwards with velocity u, at what height will the potential energy equal the kinetic energy? So they said at what height potential energy equal to kinetic energy. mgh equal to half mv squared. We cancel the masses out. We make h the subject of the formula. This will give us u squared over 2g. That is option D. The next question. Counting of currency notes with moist fingers is based on the principle of dash. A. Diffusion. B. Cohesion. C. Adhesion. D. Viscosity. Can you see? This is application of viscosity has to do with the rising or falling of something in a tube. Adhesion has to do with the forces between different molecules. So option number 10 is C. Thank you for staying to the end. See you in our next video.